Good day, everyone, and welcome to our lesson. I'm glad to have you here, and I hope you're ready to explore something that's all around us. In trees, paper, even the clothes we wear, yet often goes unnoticed. If you've ever touched paper, worn cotton, or leaned on a wooden desk, you've already met cellulose. You just didn't know how epic it was. So for today's topic is cellulose. Structure beta 1,4 linkages functions as plant structural component. So grab your notes, bring your energy, and let's dive into sugar chains that are stronger than they look.
In this lesson, we'll learn about cellulose, a carbohydrate built from glucose, yet so stable and tough that it makes up the structure of plant cells. Here's the objective for this topic. You'll understand how cellulose is built, you'll explain why it's strong, you'll see why our bodies can digest it, and you'll recognize where we find it in real life.
So let's warm up. Here's a question to think about. Think for a few seconds. Plants grow tall, stretch toward the sun, and don't collapse. What's keeping them firm? We'll answer that soon. Now let's begin with structure. Cellulose is a polysaccharide, meaning it's made up of many sugar units, but not just any sugar. Each unit is glucose, a simple sugar you probably know from the other lessons. But the way these glucose units are linked is the game changer. They're joined by beta 1,4 glycosidic bonds, and it matters a lot. Let's pause and picture that. Instead of bending and curling, these bonds keep the chain straight, like stock blocks or rails on a train track. That straight shape makes cellulose linear and unbranched. Now here's the magic. Because those chains are straight, they can line up next to each other. And when they do, hydrogen bonds form between them. For hydrogen bonding, think of it like Velcro or magnets. It's not super strong by itself, but when you have tons of them, the effect is powerful. Multiple cellulose chains stick together this way and form strong fibers, kind of like ropes woven tightly together. So remember, glucose units, beta 1,4 bonds, straight chain, hydrogen bonds, and strong fiber bundles. Let that sink in. The structure is the reason for everything else that follows. Now let's move on to what makes cellulose special in terms of its behavior, its properties. Because of that tight, hydrogen-bonded structure, cellulose has two key traits. First, it's insoluble in water. That means no matter how much water is around it, cellulose doesn't break down. Plants can grow in rain, mud, swamps, and their cell walls remain solid. Why? Correct, because cellulose doesn't dissolve. Now pause for a second. What if cellulose did dissolve in water? So every rainy day would be a disaster for plants, but it doesn't. It's stable, tough, and built to last. Second, it's indigestible to humans. Here's where things get funny. Even though cellulose is made of glucose, which your body loves, we can't use it. Why? Because our digestive systems lack the enzyme to break those specific beta 1,4 bonds. So when you eat vegetable or high fiber foods, the cellulose just passes through. No breakdown, no absorption. Think about it. Your body looks at cellulose like, nope, I don't have the tools for that. So in short, it's tough, it doesn't dissolve, and your body can't break it. Pretty cool for a sugar, right? So what's the purpose of cellulose? In plants, cellulose is the main structural component of the cell wall. It's like the steel bars in concrete. It holds everything up. Without cellulose, plant cells would be soft, unstable, and unable to stand. Thanks to those strong fibers, they stay firm and upright. Now, where do you find cellulose in real life? For the paper, you can find from the plant pulp. For the cotton, nearly pure cellulose. And for the wood, full of tough cellulose fibers. So yeah, you've touched cellulose multiple times today. You may even be writing on it right now. It's all around you, and it's all thanks to glucose units sticking together the smart way. Now let's recap everything we learned nice and easy. Cellulose is a polysaccharide made of glucose, linked by beta-1 for glycosidic bonds, forms straight, unbranched chains. Chains are held together by hydrogen bonds. Result is strong, stable fibers. It's insoluble in water, indigestible to humans. Main role is to give structure and rigidity to plant cell walls, and found in wood, cotton, and paper. Now here is a fun activity for your notes or brain break. Draw cellulose. First, make 3 glucose units in a row. Second, show the beta-1 form bonds between them. And lastly, add another row next to it. Show hydrogen bonds as dotted lines. Bonus, add little shields or smiles to make them look like plant protectors. And that's it for today's lesson on cellulose, the secret structure that keeps the plant world standing strong. Now you understand how a simple sugar can turn into something powerful, not because of what it is, but how it's built. Thanks for sticking with me. Stay curious, stay structured, and be like cellulose.